Welcome to the state pattern, one of the classic behavioral design patterns from the Gang of Four. By the end of this video, you will be able to spot this pattern in a real code base, understand the roles it defines, write a minimal version yourself, and just as importantly, know when it is the wrong tool for the job. Imagine a vending machine. It behaves completely differently depending on whether it is idle, has money inserted, or is dispensing a product. The obvious code has a status string and a big switch statement in every method. The moment you add a fourth state, say out of stock, you must hunt down every switch and add a new case. Miss one and you have a bug. That fragility is the pain this pattern was designed to cure. Here is a mental model that makes this click. Imagine each traffic light phase as a small interchangeable cartridge plugged into the controller. The controller itself never needs to know the details of any phase. It just delegates to whichever cartridge is currently inserted. When that cartridge decides its time is up, it swaps itself out for the next one. The controller's code never changes, only the active cartridge does. The pattern defines three participants. The context is the object the outside world interacts with. Think of it as the vending machine itself. It holds a reference to the currently active state object. The state interface defines every action that differs by state. Each ConcreteState class implements that interface for exactly one state, and when a transition is needed, it simply tells the context to switch to a different ConcreteState. The client never sees the individual state classes. Let us walk through this top to bottom. The vending state interface is the state participant. It declares the two actions that change meaning depending on state. Vending machine is the context. Its constructor starts in idle state, and setState lets any state swap the active object. The two public methods just delegate straight to the current state, no conditionals at all. Idle state implements the idle behavior, inserting a coin, logs a message and then calls setState to replace itself with hasCoinState. Pressing the button while idle just warns the user. HasCoinState does the opposite, dispensing the item and transitioning back to idle state. Down at the bottom, when we call insertCoin, the machine is idle, so idle state runs and transitions to hasCoinState. Press button now dispatches to hasCoinState, which dispenses and returns to idle. The final press button hits idle state again and prints the warning. No switch, no status field, pure polymorphism. Because each ConcreteState is its own class, the open-closed principle holds nicely. You add an out-of-stock state without touching idle state or hasCoinState. The context stays lean, because it is purely a delegator. One subtlety worth noting, state objects often need a reference back to the context so they can trigger transitions, which does create a coupling in both directions. That is an accepted trade-off. The cost you pay is a larger number of small classes, which can feel like overkill for simple problems. Use the state pattern when an object clearly lives through distinct modes that each demand meaningfully different logic, and especially when you expect that list of modes to grow. Avoid it when you only have two states. A simple boolean is more readable. Also avoid it when the per-state logic is trivial, because the ceremony of multiple classes will dwarf the actual behavior. Clarity always beats cleverness. If a reviewer has to learn a pattern just to understand your fix for a three-line problem, that is a signal to step back. To summarize, the state pattern models each distinct mode of an object as a separate class. The context holds a reference to whichever ConcreteState is active and delegates to it, no switch statements required. States manage their own transitions by calling back into the context. The pattern pays for itself when states are meaningful, multiple, and evolving. For simple two-state objects, it is almost always overkill. Recognize the smell, a big switch on a status field, and you will know exactly when to reach for it.